Now that we understand rational numbers a little bit better and we've got some experience with those, we're going to go back and we're going to talk about something that's really closely related to that. And I think you'll see a lot of similar things here. So this is section 6.1 and the I can statement is I can understand ratios and something called rates. So that's what we're going to start talking about here. So we're going to start with a warm-up question here. So what is an integer? So hopefully we've got this memorized by now. Again, we've talked about how some of the vocabulary words we use in math tend to be a little bit scary, but if you know what they mean, they're actually not too bad. So if somebody says we're working with integers, then we're working with positive and negative whole numbers, including 0. So including 0. And then if somebody says we're working with rational numbers, what should we think of when we hear the word rational? We should think of a ratio. In other words, we should think of a fraction, or we should think of numbers that can be written as fractions. Okay. And remember, we talked in a couple of units ago, we talked about writing things as fractions and decimals, and we kind of go back and forth between the two of those. What are the three ways to write a negative fraction? So if we take negative 3/4, we kind of pick on that one. We use that a whole bunch. We can write it with a negative on top. We can write it out front, or we can write it on the bottom. And then I'm not going to write this down, but remember, you can't write a negative on the top and the bottom. You can't write negative 3 over negative 4 because that would make it a positive quantity altogether. And then when solving an equation, how do you get rid of a fraction in front of the variable? So let's say we're solving something like this. 2/3 x equals 9, or something like that. Well, remember, we multiply by the reciprocal, so I'm going to go ahead and write that. Multiply by the reciprocal. There's another interesting word there, reciprocal. We use that quite a bit in math. Make sure you know what people are talking about when they say reciprocal. And then it says factor each expression. Again, we're going to be doing a fair amount of review here or there. You might see review problems on tests, on assignments, and that sort of thing. So please don't let these skills kind of fade away here. So we're going to factor this expression right here. So we've got 12ab minus 4a. We'll notice that it starts out with a positive, so we're going to factor out a positive, and then we've got a 12 and a 4 for the coefficients. We can take a 4 out. They both have an a, so we're going to take out a 4a. Remember, we're dividing out, we're not subtracting out, so this isn't an 8. What we're left with is a 3. We took out the a and a b, and then if we took out the 4a, if we divide 4a by 4a, we'd be left with a 1, so we're going to be left with a negative 1 right there. So there's the answer on that one. 3/5 x plus 2/5. You can hear that common factor right there, that fifth, so we're going to be able to take out a 1/5. Can't take out anything on the top, so we're going to take out a 1, and we can take out a 5 on the bottom. So we're going to be left with a 3 on the top with the x, and then we're going to be left with a 2. And again, on a factoring problem, you can always distribute through and make sure that you got it right. And then this one right here, we are going to take out a negative. We've got 4.5 and 1.5. If you can see what it is as a decimal, that's great. If you need to think of this as like 45 and 15, that would be okay. We're going to take out a negative 1.5. That means we're left with a 3x, and then if we take a negative 1.5 out of a negative 1.5, in other words, if we divide it by negative 1.5, we're going to be left with a positive 1. And remember, when we take out a negative, it changes the sign of each one of those terms. So notice how they both turned out to be positive. Okay, well, let's talk specifically about what a ratio is. A ratio is a comparison between two quantities. So there's another word that we use quite a bit in math, and a quantity is a number. So a quantity is a number. In other words, it's something that can be counted. We'll say counted here. Okay, so it's something that can be counted. And we usually write ratios one of three different ways. We write it with the word 2. We write it with a colon, like this, okay, the little dots there, and then we also write it as a fraction. And of these three, this is probably the best way to write it in a math class. So we're going to spend a lot of time writing them as fractions, but we're also going to write them with the word 2 and with this symbol, this colon symbol. So if we have two quantities we can count, we can make a ratio. If we've got two numbers, we can make a ratio. And usually we're counting things that have labels, so it's always a good idea to include the labels for whatever the items that we're counting. So if you take a look at example 1 right here, it says write a ratio for the following diagram in 3 different ways. be sure to include the labels for the quantities. In other words, include the names or the labels for whatever those numbers are that we're using. So you'll notice that we've got 4 stars, and we've got, let's see, we've got 8 moons. So we're going to say it this way. Remember, we can use the word 2, we can use the colon, and we can use a fraction. So we're going to say 4 stars to 8 moons. There, we've used the word right there. And then we're going to do it with a colon. So we're going to do 4 stars, use a colon instead of the word 2, 8 moons. And then we could write it as a fraction. So we're going to write 4 stars on the top, and we're going to write 8 moons on the bottom. Okay? Now, you may occasionally see a ratio written with another word, something like this. They may use the word 4, but that doesn't happen as often as the word 2. So they could say something like this. They could say there are 4 stars for every 8 moons. And that would also give us a way to compare those two quantities, and we can include the labels and stuff like that. Now, we usually write a ratio in what we call simplest form. So we do this the same way we would as if we were writing a fraction in simplest form. So 1 to 2, or 1 colon 2, or 1 over 2 would be a representative for each one of these. These would represent stars, and these would represent moons. So if we were to take this and we were to reduce this, this is 1, so we've got 4 over 8, so 4 would go in here once and 4 would go in there twice, so we'd end up with 1 star for every 2 moons. So that's the way it would look. If we start out with a fraction, we can go ahead and reduce it and simplify it and make it look like this. So again, what we're saying here is there is 1 star for every 2 moons. So lots of different ways to look at those. Now, we're going to turn our attention to something that looks like this. And again, all we're doing is just getting used to writing down ratios. So we've got this table right here, and it says use the table to write the ratio. So the ratio that's indicated, and notice that we've got the word 2 in this one, the colon right here, and then we've got a fraction bar to represent that particular ratio. And then it says simplify your answers if possible, and be sure to include the units. So we're going to make sure that we simplify, and we're going to make sure that we include the units. So let's do dogs to cats. So let's see, we've got 21 dogs to 9 cats. And we normally write these as fractions, so I'm going to do that same thing here. So this is 21 to 9, and I'm going to put a D here and a C here, so those are dogs and cats. Now we can actually reduce this, so let's go ahead and do that. You'll notice that we've got a 3 in common with each one of these. So 3 goes in here 7 times, so we're going to say 7 dogs to, let's see, reduce this. This would be 3 cats. So 3 goes in here 7 times, 3 goes in here 3 times, so 7 dogs for every 3 cats. So that would be the simplified ratio. Let's do birds to chinchillas. So a bird to chinchilla. So we've got birds right here and chinchillas right here. And again, I'm going to put a B here and a C here. There's nothing that we can do to reduce this. Now, the interesting thing is when we reduce this, we still want this to represent a ratio. So we would say the ratio is 1 bird to 1 chinchilla. I'll go ahead and spell the whole thing out. Okay, so that's how we do that. And again, we have to represent the top and bottom because they each have a label, and we want to make sure that everybody recognizes we've got 2 numbers that we're comparing there. So the ratio here is 1 to 1. In other words, they're equal. On this one, there were way more dogs than there were cats in the simplified form and in the original format. And then let's take a look here. This says rabbits to all other pets, all of the other pets. So we'll identify the rabbits, and then we're doing a ratio with all of the other ones. So I'm going to change colors here. So these guys are all the other ones. So the rabbits, there are 2 rabbits. Okay, so I'll put 2R. So we'll go ahead and add these. So we've got 21 and 9, so that makes 30, and then another 2, so we've got 32 of the other pets all together. So we're going to do 32 other pets, and then I'm going to go ahead and finish writing rabbits up here. So if we go ahead and reduce this, 2 goes in here once, 2 goes in here 16 times, so we've got 1 rabbit to 16 other pets. Alright, so we got our answer there. So we're going to go ahead and slide down here and take a look at the next little bit. Okay, now let's talk about a rate. Now, a rate is very, very similar to a ratio. There are some people that make a small distinction, and we're going to talk about that small distinction. So a rate is a ratio that compares quantities that have different units of measure. Now I'm going to show you what those different units of measure mean here in just a second, and I think you'll get why some people think there's a big distinction between these and some think it's just kind of a minor deal. So let's take a look at this one right here. It says write a rate for each of the following situations. So notice they use the word rate instead of the word ratio. They're very, very similar to each other. So we're going to put 150 miles on the top, and we're going to compare that to 2 hours on the bottom. And then we're going to go ahead and we're going to simplify that like we normally do. So notice that 2 goes into both of these. 2 goes in here 75 times, 75 miles, and 2 go in here once, so that would be 1 hour. So there's the simplified rate right there. Now, this is very, very similar to what we did on the other side. We were comparing birds with chinchillas or rabbits with chinchillas, you know, and all those different pets and stuff like that. So the distinction here is miles is a completely different type of measurement than hours. Miles is a measure of distance, and hours is a measure of time. So when we're comparing quantities that have different units of measure, with the pets, we were kind of counting the same types of things. We were counting animals, just how many there were. Yeah, they were different type of animals, and that's why there's that minor distinction. Here, we really are counting completely different things. We're counting miles, a distance measure, and we're counting hours, a measure of time. So let's look at this right here, $15 for 8 ounces. So if we did the $15 on the top and we did the 8 ounces on the bottom, we'd look at that for a second. We can't simplify that at all. So we would circle that and we would say that's the rate. And again, let's just emphasize this point here. You're measuring dollars, or you're comparing dollars to ounces. So you're measuring a unit of currency or a measurement for money with a measurement for how much something weighs. So that's why we would call that a rate. And then this would be 90 miles, and I'm just going to put MI for an abbreviation there. And then we're going to put 3 gallons here. So again, we're comparing a measurement for distance with a measurement for volume, how much gas we have. So then we're going to go ahead and reduce this. So we're going to get 30 miles on the top because 3 goes in here and then 3 goes in here once, to 1 gallon of gas. Okay, so each one of those are rates. Very, very similar to ratios. And again, the distinction between a rate and a ratio is not a huge deal. Notice that they've got the same beginning, basically the same root word here. So we're still talking about a ratio. It's just a measure of, you know, talking about what type of quantities we have on the top and bottom. Some people think that's a big deal. I don't really think it is, but you should be aware that some people think that that's a major difference there. Now, what I'd like to do on this example is determine whether each example is a ratio or a rate, and try and use the most specific term that applies to that particular one, and then be able to explain why you think your answer is correct. So if you want to go ahead and try these, you can pause the video, work ahead, and then see if we kind of agree. So I'll go ahead and let you do that. So as we go through and we look at this one right here, this would be 4 blue to 3 red. And you can't reduce that at all, so I'm going to go ahead and circle that. And let's see, probably I would say the most specific name that we could talk about that with would be a ratio, because they're both crayons. They're the same type of thing. Let's take a look at this one. 2 candy bars for $2.50. So I'm going to write 2 bars on the top. I'm going to write $2.50 on the bottom. I'm going to go ahead and simplify that because these are both even. We're going to say 1 bar, and then on the bottom we'd have $1.25. Now again, this is the simplified version, and the question now is, do we have a ratio or do we have a rate? Well, this is candy bars. It's something you can eat, and this is money. Probably wouldn't want to eat that. So probably the best way to describe that would be a rate. So this one's a ratio because we're comparing things that are very similar. We're measuring the same type of quantity, crayons. And this one right here would be a ratio because the things we're measuring are completely different. And then on this one right here, we've got 7 forks. Go ahead and write that out, to 11 spoons. Now, this is the simplified version. I'll go ahead and circle that. And then the question is, do we have a rate or do we have a ratio here? Gosh, I would take either. But if you had to be really specific, there would be a couple arguments. If we were to call this a ratio, we would call it a ratio because they're both utensils. If we were to call it a rate, we'd call it a rate because they're different things. One is a fork, one is a spoon. You couldn't eat, soup with a fork or something like that. So you could probably do either one as long as you had a rationale, but hopefully you can see why somebody might make an argument for ratio and why another person might make an argument for rate. Okay, what I want you to do to end this is maybe just make up a situation where you've got these numbers, and then you could just say, okay, well, if I've got these numbers, I could make up a ratio for each one of these. So we could say something like this. We could say 6 tigers to 23 goats or something like that. You could make up anything you want, anything where we're kind of comparing the same type of things. And then on this one, we could say 1,150 kids to 3 supervisors or something like that. Okay, 3 chaperones or something. Now, if we did 1,150 kids and we did 3 grades, that might be more of a rate than it would be a ratio. But again, it's very slight distinction, so I wouldn't worry too much about anything like that. We could say something like, on this one, we could say 6 cones, like cones of ice cream cones, and we could do 23 bowls or something like that. Lots of different ways to do stuff like that. So anyway, hopefully you're getting a sense for rates and ratios.